Hello everyone. In this video we will be solving the question on the task scheduler. So the question is, let's say CPU has a number of tasks to perform and these tasks can be performed in any order. But the condition is that we are given a number n and there have to be a gap of at least n intervals between two tasks with the same label. For example, if there are two same tasks that CPU has to perform and we are given n is equal to 2, then in the first interval, let's say a task is completed. Okay, we can consider in the question that each task can be completed in the single interval. Now next, the CPU has to remain idle. Now again, as there has to be a gap of 2 intervals in the next interval also, again CPU will be idle. And then CPU can perform the same task A. So here CPU has taken 4 intervals to execute the two tasks. The target here is we have to find the minimum number of CPU intervals required to complete all tasks. Let's take another example. Let's say we have 3 tasks of type A, 1 task of B and 1 task of C. Now let's say if CPU executes the task A first, then let's say B, C, A. Now let's say n is given as 1. That means there should be a gap of 1 interval between two same tasks. Now 2 A's are done, 1 B is done, 1 C is done. There is 1 A which is remaining. But the next option I have, I cannot perform A over here. So here now I have to first wait for 1 interval. Then the CPU can execute the next task which is of A type. So this is one way in which CPU can execute all of these tasks. So how many intervals are taken by CPU in this case? 1, 2, 3, 4, 5, 6. 6 intervals. We have to find the minimum. Now let's try another way. Let's say CPU first executes A, then B, then again CPU executes A, then C, and then again A. In this case, we can see between two same tasks, there is always a gap of at least 1 interval. Can be seen over here. In this case, 5 intervals are taken by CPU to execute all these tasks. So the answer to this question is 5. That means CPU will require the same intervals as the number of tasks given in the question. So for this question, we have seen that we have tried 2 ways, but with one we got the minimum answer. So what change we have done that reduced our execution time, basically the number of intervals that the CPU required to execute the tasks. Let's try to observe that. So what we had in this question, we had 3 A task, 1 B task and 1 C task. Now can we observe from here that if we pick up the task having the maximum frequency, here it was A first, then it is possible to find a sequence of operations that will result in the minimum intervals of time. Can we say that? So let's say here there were 3 A's, 1 B and 1 C. Let's first pick A. So we will remain with the 2 A's, 1 B and 1 C. Now again A is the most frequent element, but can we execute A next? No, because we have n is equal to 1. That means there should be at least 1 interval gap between the two same tasks. So we cannot have A at the next. So can we have B or C? Let's choose the next most frequent element. So it can be either B or C. They both have the same frequency. That is 1, 1. Let's execute B. Now we have two A's and one C. Now again 2A. That is A is the most frequent element. We can execute A. Now we are remaining with 1A and 1C. So we can execute C now, because the next most frequent element we have to execute following the constraint that there should be at least n intervals between the two same tasks. Here n is 1. Now only A is remaining. We can execute A. So how many intervals? 5 intervals. That is same as the number of tasks given in the question. In this case, there are cases where the CPU has to be idle also. We will look into that also. For example, we have 2 A's, 1 B, and there has to be 2 intervals between the two same tasks. So now the most frequent element is A. We can perform A first. Then now we have A frequency 1 and B frequency 1. We can perform B. Now only A is remaining. Can we perform A at the next execution? No. So CPU has to be idle. And now I can perform A. So how many intervals are required here? 4. So based on this observation, we can say that we have to execute most frequent tasks first. Now let's try to come up with some mathematical logic. Let's consider we do have 3 A's and 3 B's with n is equal to 2. Let's consider n is equal to 2 over here. That means there has to be 2 intervals between two same tasks. So here, what if I try to place A first, considering the minimum number of intervals between the same task? That means A now in between this we have 4 positions available, and we do have in the last also we can insert some task. So we have 3 B's over here. Now we can start inserting B. B can come here, here, and then here in the last. So what would be the answer for this? 1, 2, 3, 4, 5, 6, 7, 8. 8 intervals minimum. Now let's try to find the formula. Let's say the most frequent task types here was 2. Let's consider it as. So since both A and B has the same frequency, that is 3, so the most frequent tasks types are 2. And what is the frequency? Maximum frequency, that is equal to 3. So there are 2 types of tasks which are having 3 frequency. Can we say the number of minimum intervals are 3 minus 1 into n plus 1 plus s. This 3 is nothing but the maximum frequency. So here it is 3 minus 1, which is 2, into n plus 1. N is 2 here, it becomes 3 plus s is 2, it becomes 8. Now how this logic works, let's understand that. So we placed a and we kept some idle time for CPU between the a. That means here, other processes can be executed at this time. So if we would have B, C, D, E, we could have placed them over here in these gaps. So how many gaps would be there in the k tasks? If the task has k frequency, let's say a is 3 times over here, there would be 2 gaps. That means f minus 1. Now we are multiplying it, that is the number of tasks that can be placed over here. That is n is equal to 2. But since we have to find the number of intervals, total number of intervals that is required by the CPU, we have to consider this a also. And hence here it becomes n plus 1. So what we are saying? We are saying 2 into 3. So that this we are saying. So for this account to 6 plus if only a was there, that means only we do have a and n is equal to 2. That means s is 1. There is only one task and that is only the most frequent task. So s is 1. We would be adding 1 to this and this would come to 7. Now why are we adding 1 to this? We have to consider this task also. Understand? Now why are we formulating it this way? Because let's say in the above question there were 3 A's and 3 B's in the previous question basically. That means A, okay. So that calculation remains same again, that there are f minus 1 into n plus 1. F minus 1 is 2, n plus 1 is 3, that becomes 6. Fine, till here it is fine. We can place B also here, but there has to be idle time also, because there has to be minimum 2 intervals between the 2 same tasks. So we have to ensure that there are 2 intervals between the 2 same tasks. Okay, now till here we have calculated. Now we have to place 1b over here also. To consider this, we have to add 2 over here, and this is nothing but the number of most frequent elements, that is a, b. There are 2. Let's take 3. For example, a, b, c. Again we are having n is equal to 2. So let's place a first. So what we have, n is equal to 2 we have. So n plus 1 is equal to 3. The maximum frequency is 2. So f minus 1 is equal to 1. And s is equal to 3, because all of these having the same frequency 2, which is a maximum frequency, and there are 3 types of tasks which are having the same frequency, that is maximum. Here 1 into 3 is equal to 3, that means till here it is fine, and we can place 1b here, 1c here to satisfy the conditions. Now we are remaining with 1b and 1c. We have to place them here. Till here we got the answer from f minus 1 into n plus 1. Now we have to add s, which is equal to 3. So that means the answer would be 3 plus 3 is equal to 6. 1, 2, 3, 4, 5, 6. That is the minimum number of intervals required. Now what happens if I do have something like this, where a, b, c, d, e. Now what is this? Here we do have, let's say n is equal to 2, but we have quite a lot of tasks basically, which are less frequent. So the maximum frequency is of a. So the number of tasks which are having maximum frequency, which is s, it is equal to 1, and the maximum frequency it is equal to 2, and n is equal to 2. So again, let's try to place. It becomes a, idle, idle, and then again we can perform a. So this is what we have done. We have placed the most frequent tasks first. Now we are remaining with B, C, D, E. So as per this formula, the answer that we get is f minus 1, that is 2 minus 1 into n plus 1, which is 2 plus 1 plus s. So it is 1 into 3 plus 1, that becomes 4. But here if we check, the answer should be 6. So what is the catch here? So one thing is that our final answer would always be max of n, which is the number of tasks, total number of tasks which are given, or the answer that we get from our formula. Now why is it so? Because what we were doing with our formula is we were calculating the number of intervals considering the idle time, that minimum that we have to have. So if the most frequent element, we have to place them first. We have to get, okay, to perform these tasks, at least we have to have these intervals, at least. But if the number of tasks are much more and they are so different that there has to be no idle time, then we have to consider that, okay, we don't need to worry about the idle time, and we can place B, C, D, E like that. So either the number of tasks which are given, we can take that much time. And when is that case? When there is no requirement of idle time. But if the number of tasks are smaller, let's say, as in the previous cases we have this AAA, triple B, so 3 A's and 3 B's. So here number of distinct tasks are smaller, or only 2, and we have n is equal to 2. That means we at least require 1, 2, 3, 4, 5, 6, 7. We at least require 7. Now on top of this, when we have B, to place B, that becomes at least 7 plus 1, 8. Okay. If there were 2 B's, then we would have required only 7. That means maximum of this or this, whatever the maximum, that will be our answer.